Hello friends, I am Amir Nizami and today we are going to study just continuing the last classes of the generating ABD matrices for laminated composite plates. So first of all we will see the examples, next examples here. So here in the last examples we have seen that we were given epsilon naught xx. Okay, so stretching epsilon naught xx were given and then we have solved the examples. Now in these examples, we have given epsilon 1 xx because here epsilon 1 xx is the bending part, not the stretching part. Okay, so from classical laminated plate theory, if you will see, so epsilon 1 xx is the bending part. Okay, not the stretching part. So therefore, this bending part is related with z times epsilon 1 xx, and here the stretching part is 0, therefore epsilon naught xx is 0 plus z times epsilon 1 xx. So the epsilon 1 xx is given value 1 by 12, and then they have calculated the stresses sigma xx, sigma yy, sigma xy, and the axial stress or axial forces are 0 because there is no axial stretching. Okay, epsilon naught xx, yy is all 0, but the bending moment is there because we are having epsilon 1 xx, okay, which is the bending strain. So therefore, we are getting an xx and yy. So now we will solve it using our code. So let us start. So we are having the same code we have written in the last class. So right now we are just continuing with the new examples. Okay. So right now we have to change from these matrices would be the same. Okay, yet same. Now epsilon naught xx here is 0. Okay, so this would be, for this example, we can do one thing. We can just comment it, comment, and for the next example we can see uh, example 3. We can say for this example what we are having epsilon on x is 0, epsilon yy not 0, gamma xy not 0, but epsilon xx1 is 1 by 12, 1 divided by 12. Okay, this is the value we are having. Okay, so therefore epsilon xx would be epsilon xx naught plus z times epsilon xx1. Okay, so we will get this, and epsilon yy are 0, gamma xy are 0. So therefore epsilon xx, epsilon yy, gamma xy would be in the vector form transpose. Okay, now stress is nothing but Q matrix times strain vector, so which we are having the formula here written. Stress is nothing but, here we have seen the formula above, Q matrix stress is nothing but Q matrix times strain. Okay, strain is epsilon xx, yy, gamma xy. Therefore, and this Q is the transform matrix. So we are already having our transform matrices. Okay, now we want to calculate the bending moment and the axial forces, resultant axial forces. Okay, so resultant axial forces would be 0 because we know that the stretching part is 0 everywhere. Okay, so now we will run the code and we will see what we will get the value results. So before that we will see in this code, in this notes, the example third, what he mentioned here, and the third examples, loads that non-zero, there is epsilon xx, these stresses are this. So in plate of example 3 when is subjected to loads such that only, okay, so it is the continuation of the last example 3.6.2. So this is the example, orthotropic plate is subjected to loads such that the only non-zero strain, here it was a non-zero strain but it is changed there. Okay, material properties are the same, and assuming that the plate thickness is 0.01 inch. Okay, 0.01 inch. So it is also continuing equation 3.6.22. 3.6.22. Okay, this example it is continuing. So 0.01. Let's do. We will run this code first. So what we are saying, we are having 2.9125 in YY, but it should not be there. We have to run it again. Enter the number of composite plate lamina, let it 1. Enter the height 0.01, 0.01, and let's keep it. I think it was maybe 60 degree or 0 degree, I didn't remember. Just let it. So then the bending moment we are having, okay, mxx and yy, m vector we are having, and nxx and yy, nxy is 0. Okay. So there is no stretching part, therefore there would be no axial resultant forces. Nxx and yy, nxy is 0. Okay. But we are having the strain epsilon, bending strain epsilon 1 xx. So therefore we are getting the bending moments in xx, yy, and xy direction. So we have given rotation angle as 60 degree. If you will give 0 degree, then let's see what we find the difference. Number of composite laminate is 1. Enter the height of the laminate as 0.01, 0.01, and 0 degree orientation means fiber axis coinciding with the laminate axis. So mxy is 0 now. Okay, and mxx is 0.1397 and myy is 0.0027 and mxy is 0. So let's match with the results here. Example 3. So 0.1397. Okay, we are having this 0.1397 here. Okay, then myy is 0.0027. So here we are having 0.0027, and then the mxy is 0 here. So mxy we are also getting here 0. Okay. Similarly, we can play with various examples. Okay, various laminate sequence. We can have 3 lamina. If we will run it, suppose we run it, and we give 3 laminate. Number of composite laminate is 3. Okay. Enter the height of the laminate. Let us have 0.3 height. Now, first one is 0.1 inch, then 0.1, 0.1. So, summing all, 0.3 would be the total height. We are having 0 degree, 90 degree, then 0 degree. So, we are having mxx, mxx, myy, and mxy is 0 because 0, 90, 0. So, it would be the value. And axial force, because there is no axial strain, therefore no axial resultant forces would develop. Okay. So we have seen this example. So we will close here. Thank you.